All right. So, folks, um, the two main things that I want to teach you today is the yellow highlights. That's really the two main things that I want to teach you today. Let me just create a brand new slide for this. Right over here and here. Okay. Now, once you know those two yellow highlights, everything else is going to be very easy. Okay. So now, what are we doing? Okay. What is this? Let's zoom out and talk about what we're doing. What we're doing is this is going to be basically substitution on steroids. Okay. So imagine if you have a sentence that reads like this. I have $1 and and 50, let's just 50 cents. Okay, let's say you have that sentence. Okay. You know that $1 equals to 4 quarters, and you know that 50 cents can be subdivided into 10 dimes. Okay? All right, so let's say we have that. Okay, well, you can turn this sentence into, you can say that I have 4 quarters and 10 dimes. Okay? So this is a very simple sentence where we use some very simple substitutions. Okay? Yeah, so that's basically the gist of what we're going to be doing, but with trig. Okay, it's just basically substitutions. Okay, so now if I teach you the yellow highlights, you basically know. If I teach you this yellow highlight, let me just put it this way. If I teach you this yellow highlight, you know that pink highlight. Whoa. Then you know this pink highlight. Okay. If you know this top yellow highlight, you know these pink highlights. Okay, and these, believe it or not, you pretty much already know. Okay, you already know. Okay, so let's start with the easiest ones here. Okay, now let's start with these greens. Remember, sine is basically opposite over hypotenuse, and cosecant is the reciprocal of that, hypotenuse over opposite. Okay, you're just going to flip that over. Okay, so that is why you have this green. Okay, you can also rearrange the green to look like this. You could also say that sine equals to 1 over cosecant. It doesn't matter. Okay, in this case, it does not matter. Okay, as long as something is equal to the reciprocal of the other thing. Okay, excuse me, something is going to equal to 1 over the other thing. It doesn't matter how you arranged it. Okay, and the same idea goes for the other green highlights. Okay, so we're good with those. We should be good with those greens. Okay. Now let's talk about this yellow. I think I may have talked about this yellow before. Okay. But let's start with, let me prove this yellow for you. Okay, to you rather. Okay. Tangent is equal to, what I want to prove to you is that tangent is equal to sine over cosine. That's what I want to prove to you. Okay. We know that tangent is opposite over adjacent. We know that sine is opposite over hypotenuse. Okay. We know that cosine is adjacent over hypotenuse. Okay. all right? And what happens to the hypotenuse? They cancel. And so now you're left with opposite over adjacent is equal to opposite over adjacent. And that means tan indeed is equal to sine over cosine. So we should be good with this. Okay, excuse me, with this. Okay, now remember, cotangent, okay, cotangent and tangent, they are reciprocals of each other. Okay, tangent is opposite over adjacent, and cotangent is adjacent over opposite. Okay, well, let me just explain it this way. The longer way of explaining it is not even that much longer. Okay, cotangent, I want to prove to you, is cosine over sine. Okay, cotangent, you agree, hopefully, that it's adjacent over opposite. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Okay, I'm going to cancel the h's, and I get a over o is equal to a over o. Okay, I think that's the easier way of proving it. Okay, so now I just proved to you both of these on the left side. Okay. Now, I have to prove to you this yellow one right here. Okay, I want to prove to you this yellow one. Cosine squared plus sine squared equals to 1. Okay. Okay. Here it is. Let me bring that up here. Okay. Okay. Now, let's look at this line right here. Okay. Let's start with the Pythagorean theorem. Ignore this red arrow right here. Okay. Ignore that red arrow. Let's start with the Pythagorean theorem. Okay. Adjacent squared plus opposite squared is hypotenuse squared. Okay. Adjacent squared plus opposite squared is hypotenuse squared. Okay. Now, watch this. Okay. I would say this is the quote-unquote hardest step, and it's really not that hard. It's just a little bit weird at first. Look at how they rewrote this green into that green. I want you to and ignore the exponent for now. I want you to see how those two green highlights are actually equal to each other. Okay? The reason they're equal to each other is because you can literally just cancel out the hypotenuse, okay? And you'll land back at adjacent. Okay? You'll land back at adjacent. Okay? I mean, you can do some simple arithmetic math. Check this out. Is 5 the same thing as 5 over whatever? I'm going to call this x times x. The answer is yes, it's the same thing because you can just cancel out the x's. Okay? You just cancel out the x's just like you can cancel out the hypotenuse. Okay? So those two are exactly the same thing. So all they're doing is adding a hypotenuse as a denominator here and something multiplied by over here. Crap. I press undo too many times. There we go. And one more time. Okay? And they did the same exact thing with the opposite. They used the same exact logic. Okay? And height, they just kept it the exact same thing. Okay? They just kept height exactly the same thing. Okay? All right. Now, watch this. Adjacent over hypotenuse is basically cosine. Opposite over hypotenuse is sine. Okay? Look at how those yellow highlights are equal to each other. Okay, ignore the blue strands. And then we're gonna revisit the blue strands and we're gonna distribute the exponent. Okay, and we get that so far. Okay, that's what we have so far. We're almost done. Bear with me. Okay, we're done. We're 90. I would say we're like 98% done. Actually, we're 99% done, to be honest with you. Okay, now last step. I'm gonna divide everything by hypotenuse. Okay, I'm gonna divide everything by hypotenuse. Okay, look at the blue. Look at the blue, what I divided by and everything in blue. This is going to cancel. Okay, cancel, cancel. And this becomes a big fat 1. And we're left with basically cosine squared plus sine squared equals to 1. Okay? That's what we're left with. Okay? Now, so I just proved to you why cosine squared plus sine squared equals to 1. That's the most important identity that we're learning. Okay? Now, all these pink highlights underneath are basically a rearranging of this. Okay? Let's start with this pink highlight here. Boom, boom. Okay? Let's start actually with the first pink highlight. To get the first pink highlight, what they did is subtract cosine squared from both sides. Okay? And we get sine squared equals to 1 minus cosine squared. Okay? All right. Up. Now, to get this pink highlight, okay, what they did is minus sine squared from both sides. Okay? And you get cosine squared equals to 1 minus sine squared. Okay? Now watch this. So that's the pink highlight right there. Now let's look at this pink highlight here. Okay. How did they get to that pink highlight? Well, all they did was divide everything by cosine. Yep. They divided everything by cosine squared. So if I divide everything by cosine squared, 1 over cosine squared becomes secant squared. Remember, cosine and secant are related to each other by reciprocals, by being reciprocals of each other. Sine over cosine squared is tangent, and cosine squared over cosine squared is 1. Okay, and that's how they got that pink highlight over there. Now they got the last pink highlight by dividing everything on the yellow by, you guessed it, sine. Okay? Sine squared. Remember, 1 over sine squared is the same thing as cosecant squared. Okay? That's what this comes from. Sine squared over sine squared is 1. And cosine squared over sine squared is cotangent squared. Okay? So there you go. All right. Cool. So now I just basically proved to you everything here. Okay? Let's go ahead and work some examples here. Okay? Bear with me, folks. I know I'm talking a lot. I'm going to go through some examples, and how this is typically taught is that teachers are just like, hey, here's the substitutions I want you using. Here's the tools in the toolbox I want you using, and let's do some problems here. Okay? And I don't want to do that in this particular case. I want to explain how these tools came about. Okay? So let's go ahead and take a look right over here. Okay, come on, computer. Jeez, man. So So slow. Okay. Now let's look at the top one. Okay. Let's look at the top one. Let me actually bring in the blue box. I want to just have it. I want to have the blue box right in your face and available. Okay. So the blue box, let's go ahead and bring it in here. Okay. Let me just make that a little smaller. Okay. Sine squared equals to 1 over cosine squared. Okay. Well, check this out. We know that sine squared, I'm right here. All right, let me do it in green. We know that sine squared is equal to 1 minus cosine squared. Okay. So I'm going to just cross that off. Okay. And we can factor 1 minus cosine squared. So as of right now, this is what we have. Okay. Now check this out. We know that we can factor the top, the numerator, to be 1 plus c, 1 minus c. Okay. And we know the bottom is going to be 1 minus c. We just copy it. And guess what happens? Cancel. Okay. Cancel. Okay. Now, the second example is pretty much the same exact thing. Okay, this is the same exact thing, just different. We're using cosine now. Let's look at this one. Okay, let me move that up here. And let's look at this one here. Whoops. Okay, let's look at this guy here. Write secant minus tangent times sine in terms of cosine. Okay, so secant is going to be, okay, secant is going to be 1 over cosine. Okay, look right here. Boom. Okay, tangent is sine over cosine, and sine is just sine. Okay. All right. So as of right now, I get 1 minus s squared over c. Okay, remember, so the s squared obviously came from here. And remember, when you add, subtract fractions, you keep the denominators the same after they match. Okay, let me say it this way. When you add or subtract fractions, if the denominators match, you keep it exactly the same. Okay? Now remember, 1 minus cosine squared, or excuse me, 1 minus sine squared is the same thing as cosine squared. And c squared over c is just basically, you have two c's on top, 1 on bottom. How many's left over after canceling? The answer is 1 on top. Okay, or 1 left over. Okay? Okay? And let me just show you. Let me show you that last one. Okay? Here, let's just do it. Okay. 1 over secant squared. Okay, 1 over secant squared is just basically the same thing as cosine squared. Remember, you can rewrite this as 1 over secant equals to cosine. Remember, I told you that earlier. It doesn't matter how you arrange it. As long as one is if you write one of them, the other one is 1. If you write cosine, what's a good way to put it? Actually, I'm going to leave it the way I'm going to leave it the way it's written right here. Either one works because I don't want to overcomplicate it. And this basically equals to cosine squared is basically, again, equal to 1 minus sine squared. And you're done. That's it. Okay, you wrote it. You achieve its request. Okay? All right, I want you guys to do the problems. Use this blue box to do substitutions. Okay? And do the problems that you are going to see on the screen. Hang tight.